Right, so this is where we left off, talking about strings. And the big thing here with strings was they're definitely a little different than like just a number or a Boolean or something. And they're not just different in the sense that like, well, we're defining them differently, but you know, like intrinsically there's like a difference. If we have like an individual letter, okay, and an individual like number, and remember also, do not confuse how we as humans represent the number like 1,000 as 1, 0, 0, 0. Yeah. And what it means, right? The computer doesn't care that 1,000 is represented with 1, 0, 0, 0, right? It's just the value 1,000 is a value 1,000. We represent it one way. When it comes to like strings though, it's different because the computers need to know like, okay, well, if it's that word hello is H-E-L-L-O. But that's actually like H-E-L-L-O, that's 5 pieces of information. Where like a single number is 1 piece of information, and 1 piece of information fits nicely into all of our like memory addresses. And again, it doesn't work like this technically, but at a more general sense, this is the idea. Imagine each seat in here is a memory address. I could put the number 1,000 in this seat. I could put the number 1,000,000 in this seat, and I could put the number -44 in that seat. It doesn't matter. Each number fits nicely in a seat. Each letter fits nicely in a seat. But when I have a string that is 5 letters, I'm in trouble. I can't shove 5 letters in one seat. There's not enough room. If I tell 5 people to sit in one seat, it's going to be uncomfortable. It ain't going to work. So what do? Well, we just put each letter in one seat next to each other. And there we go. Problem solved. We have H-E-L-L-O. We're in great shape. So a string is actually like an aggregate of smaller pieces of data. And what's interesting about a string, and a lot of you have done this inadvertently, accidentally, in lab, like if I print out some string, whoop, we see the whole string, but I can index the string and say, give me the letter at index 0. We get H, capital H to be more specific. Index 1, well, that's the E. L, and well, there's 2 L's next to each other, so 2 and 3 are both L, and then 4 is O. And what's at index 5? Well, nothing. There is nothing at index 5. If I ask you, like, well, starting at 0, what's the 5th letter of the word hello? You go, there isn't one. You might say, well, no, it's O. Well, no, remember, we start counting at 0, right? H-E-L-L-O. That's 5 things. 0, 1, 2, 3, 4. I only counted to 4, but I have 5 fingers up because I started counting at 0. Because remember, if I have the string hello, H-E-L-L-O, when I say go to some string and take 0 steps, I'm at the H. If I say take 1 step, I'm at the E, and so on. So any questions? This is review from Friday. Whoops. Nope. Nope. There we go. All right. Yeah, okay. We start counting. Yeah, okay. Yeah, let's do this quick activity. So write a single line command to print out the first 4 characters of some string. Then how about the 2nd to 7th character? And you know what? Actually, let's not do this activity. I'm going to show you because here's what you would first do is you would like, okay, well, I want the H, 1, 2, 3. This is some string. Here's some arbitrarily long string. If I want to print out the first 4 characters, well, I can only get 1 character at a time. So how am I going to do that? Well, we can do at 1 and so on, right, to do it. And this will work. But Python actually has a neat thing built into it. Not many programming languages do this. Not many of like the big ones, at least, like the common popular ones. Python has this weird, interesting thing called slicing. And slicing is a way to say to Python, hey, I want some like range of those letters from your string. What I can say is 0 through 4. I use that colon. And I get 0, 1, 2, 3. And you know what, let's, there. To make it clear that we're not getting any more S's, we didn't include the space. I only get the first 4 letters. Starting at 0 and go up to, but excluding 4. This is the general pattern, by the way, in like almost all programming languages. Whenever you are defining a range, start here, end there. The here, the 0 is inclusive. You start at 0. But when I say go to 4, it means go up to, but exclude 4. So go 0, 1, 2, 3, but don't go to index 4. That's the general pattern. And if you're wondering why, there is actually a lot of, at the end of the day, you can make an argument that it's entirely arbitrary. Someone had to make a decision, well, do we include the 4 or do we not include the 4? Someone did make a decision and we stuck with that convention. But the decision was very, very, very well motivated. We won't go into the details of that, but there is a very good reason why we start at 0 and why we always include the thing on the left but exclude the thing on the right whenever defining a range. By the way, it's just some trivia. So that is a nice way to say start at 0, go to 4. I could say go to 2 to 7, start at 2, go up to but exclude 7. So that would be 0, 1, 2, 3, 4, 5, 6. But we don't include that space. Can we confirm that? Yeah, there's no space there. If I said go to 8, let's see if we can get that space. Yeah, we can see there's a space there. Yeah, cool. So this is a nice way to say, give me like a range of things. It's called slicing. If this was Java, this isn't a thing. At least not this simply. To get like slices, they call this. This is a Python thing. Now, if we go back to the 0, 4 example, what's neat here is whenever doing slicing, if you want to start at the beginning and go to some arbitrary point like 4, you actually don't need to specify 0. If you don't include anything as the start, it assumes you want 0. Similarly, if I said start at 3 and go to don't include, it means just start at 3 and go all the way to the end. And finally, here's some interesting thing. 8 colon 2. No, that's a boring one. Let's say like 15. Anyone have any idea what this one's doing? See if you can figure it out. If you can't figure it out, you're normal. If you can, you're weird, but maybe you can figure it out. I'll give you a hint. I'm going to change this to this. Okay. Okay, this part is lame. Let's get rid of this. So now it's a little bit more normal. There. Okay. I'm going to change it to a 2. I'm sure someone in here can figure it out. It looks like you might have it. It skips it. Yeah. It goes to 3 and then it skips 2. Yeah. So there actually is this secret third option, which means end, like count by. So start at 3, go to 15, and count by 2s. So go to index 3, then 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. But we don't include the 15 because 15 is not less than 15. So when I put in a 1, it means and count by 1s, which is the same thing as, well, saying nothing. Because by default, it'll count by 1. But that's like an interesting little piece of trivia. Yes? What if you count by -1? Well, let me ask you this. If I say, go from 3 to 15 by counting by -1s, that's not an option, right? You can't. How many numbers are between 3 and 15, starting at 3, going to 15, How many steps do I have to take to get to 15 if I'm counting by negative ones? I can't. It's going to say, well, there are none in that set. How many indices are there between? But let me ask you this. What if I were to say, start at 15 and go to 3, counting by negative ones? Well, that's fine. So there you go. If you're like, wait, what? You're thinking too hard. This makes perfect sense. Despite how weird it might feel at first, it does make perfect sense. Start at 15 and go towards 3 by counting backwards. Perfect. I can do that. 15, 14, 13, and so on. Anyways, this is more just trivia. You can do this. This is called slicing. All right, okay. So we learned about while loops. But you have all, assuming you did assignment 1, you have all done for loops. Now, you didn't write it, but you used a for loop. And a for loop is, it's just a while loop, okay? A for loop and a while loop are the same thing, but a for loop is effectively just syntactic sugar to make a particular way of looping a little easier syntactically. By the way, when I say syntax, I mean by what we are writing. Because what we write and what we mean, we want them to be as close as possible, but the physical syntax is different from its actual meaning. They are separate things. So a for loop and a while loop, they just loop. Repeat this code until some condition is true. But a for loop is a specialized version that makes a certain style of looping easier. And that style is, look, every once in a while, we are given a situation where we want to loop for some arbitrary condition. Yeah, you use a while loop. But sometimes you will get a collection of information. It could be a list of Starbucks locations. It could be a list of cities. It could be a string of letters. Some collection of information. Now, it doesn't have to be, but often we would say, in this particular situation, for the sake of learning, we could call it a linear collection. When I say linear, all I mean is the data kind of comes in a straight line. If I told every one of you to line up in order, no, let me ask you this. What comes after the number 1? 2, right? Yeah. Why? Well, because that's the way it goes. If I say, what comes after red? I don't know, right? That's kind of a weird question. Yeah, sometimes there's no order to things, and sometimes there is. Right? So a linear collection is a collection like a string hello. What comes after the letter H? E. Why? Well, that's how words work. Right? What comes after the value at index 0 in a list? The thing at index 1. Why? Well, that's how lists work. There's an order to it. Whether the order has meaning is irrelevant, but there is an order. Right? Like the Starbucks locations, they weren't really sorted by anything. They were just Starbucks locations. But they did have an order. There was something at index 0 and something at index 1 and something at index 2 and so on. But why were they in that position? I don't know, but there was an order. So if I have a linear collection and I want to do something for each thing in that collection, I can write a while loop. The easy way to do that would be okay, what's the length of that collection? Create a counter, start the counter at 0, check if the counter version, the current value of the counter is less than the length. If it is, do something, increase the counter, repeat. Right? I can do that. That'll work perfectly fine. That's a very general purpose solution. But sometimes we just don't give a shit. We just want to say, just repeat this code for each thing in the collection. That's where a for loop comes in. When we use loops like this, a for loop like this, we would say this is more of like a for each loop. For each thing in some collection of things, repeat this code. So we can find the length of any given string with len of some string. And we know we can index individual characters from a string. Let's write a function vertical print while that prints a string vertically 1 character per line. So here we go. I'll get rid of this. There we go. Perfect. Makes sense. Why is this working like this? Well, this is a function that takes a string. It produces no output because it's got some prints inside of it, which is fine for demonstration purposes. And what do? Well, we start with the character index 0. That is effectively going to be our counter. Well, the character index is less than the length of a string. Okay, perfect. And remember, we're doing less than the length of the string, not less than or equal to. Because if the length of the string is 5, what's the last index? 4. We never want that index to get to 5 because there is no index 5 in something of length 5. Remember that. So, for the character index less than the length of the string, print out a string at that character index, increment the character index, repeat until we're hit the length. And that's what that code is doing. Make sure this is perfectly clear. So assuming this is perfectly clear, okay, we have our counter basically. We've got a while loop. We've got our condition. Well, the counter is less than some defined length, the length of the string. Character index, we increment. Okay, it's the general structure of a while loop. Now, this code is by no means overly cumbersome or complex. That's a given. It's not too bad. But with a for loop, we could do this a little easier. A little easier syntactically. It's functionally the same thing. It does the same thing, but the syntax is a little nicer. What does this say, right? Yeah, whatever. Okay, the while loop works perfectly fine, but there's another type, for loop, that may feel a little nicer to use in this scenario. These for loops are great for when we have a collection of things, and we want to do something for each of those things. So here's the code. Vertical lint print 4. Let's get rid of the docstring for brevity. And look, yeah, clearly, look. The while loop is 1, 2, 3, 4 lines of code, and the for loop is 2 lines of code. Fine. It's not like, oh, 4 lines of code is too much. I get it, fine. But it is a little nicer. So what does this code say? So in general, remember, it is for each thing in a collection of things. So for each letter in a string. For each Starbucks location in a list of Starbucks. For each city in a list of cities. That's what this is saying. Now, everyone, pay very close attention, because every year I say everyone pays very close attention, and every year half the people in the room mess this up. And I don't want you to mess up. Please break the combo. Look, I'm saying for char in a string. Char is just a variable name. It's just a variable. It's a stand-in variable for each thing in the list. The first time through the list, char, if I give it the string hello world, the first time through that loop, char is a variable holding the value h, capital H. Next time through the loop, it's a variable holding the value lowercase e, lowercase l, lowercase l, lowercase o, space. That's what's going to happen. The fact that char is called char is not necessary. It is a variable name I picked because it's a good variable name, because this is a string and strings has characters. But it does not need to be char. That is not a requirement. Let me hit run, vertical print 4. It worked. So char, first time through the loop, char, a string is hello space world exclamation point. First time through the loop, char is what? Capital H to be more specific. Next time char is? And what did we do? We print it out. Next time it's? L, and then we print it out. Go repeat the loop. And we repeat, and the loop stops when we're out of things. When we're out of characters in the string. When we're out of Starbucks locations in the list of Starbucks locations. It stops automatically for us, which is nice. The while loop, we had to be a little bit more, we had to like muscle it into place to do what we wanted by making the loop and checking the length and checking that the counter was less than. That's fine, but the for loop did that for us. To hammer the point home that char can be called whatever the hell I want, it works just fine. Now, that is a terrible variable name, but it'll work because it's just a variable name. I called it char. Let's call it C. C is fine in this scenario. C for character, that's fine. Could I have called it X, Y, Z? Of course I could have. That's fine. Now, does this matter? Yes. At least it does matter based on what, well, the attribute's called. Or sorry, the parameter is called. Attribute, pardon me, the parameter. The parameter was called a string. What did I want to loop over? A string. That's the thing I'm looping over. For each thing in some collection of things. Now, I could do this, but that's rather silly. It's not very helpful. First time through the loop, X, Y, Z will be uppercase H. I immediately assigned the value 1, 2, 3. I just repeated this. How many times would this have repeated? Exactly. This loop will run for each character in Hello World. Space, exclamation point. It will. It's not very useful, but it did. I'm just making sure it's clear. Now, actually, when I do this, let's just do this. Look at this code for a moment, and I want you to tell me what you think is going to happen. Depending on how you look at this, this might be considered a bit of a trick question. I will maintain that it's not, but one could make that argument. Here's my hint. Don't think too hard about it. The answer should be clear if you follow all of the rules we've done so far. Were you right? Yes? Raise your hand if you were wrong, because if you were wrong, your head's in the right. You're not. You're wrong, but I know why you're wrong. And the reason why you're wrong is intuitive. But you were trying to be smart, I bet. So, you said you were kind of maybe wrong. What were you thinking maybe?
Like just 5 lines.
You thought hello was going to turn into, oh, you didn't know, okay. Interesting. Interesting. So more on that idea shortly. Let me put it this way. I see your hand, just give me a second. This is a variable that gets assigned the value of uppercase H. Immediately that variable is overwritten with the value Y. So the variable had no effect on what was in the string. The variable just, oh, the first letter in that string is an H, so we're going to take that H and put it into this variable. We immediately throw it away to put a y in there, and then we print it out. But that h over there was left alone. What were you going to ask? So why did you think that?
I don't know, I was thinking a little bit too hard.
Probably. Classic mistake. Stop trying to be smart. I'm telling you, huge mistake. All right, so let's go back to what this used to look like. Yeah. There. Cool. Any questions or anything about what you're seeing right here? Now I want to make sure I didn't skip something important. Okay, cool. Nope. Yeah, okay, loop, okay. Yeah, vertical print 4. For example, yeah, this is just me saying for terrible variable name in a string, print terrible variable name. What we put in here, it's just a variable. This matters because this is the source of the data. In fact, look at this. This will work. I mean, it's a literal, so it's not very helpful. Like functionally, what does this do? I mean, okay, right? So what I mean is, I didn't put a variable in here, I put in the literal hello. I can put in the list 6, 3, 88, 12, and it'll still do its thing. But usually you're not putting in a literal on the right-hand side, you're putting in a variable that stores some value. So any last questions before I move on to something that may or may not make you very angry? So now's the time to ask before you get angry about anything. How angry? Oh, probably only a little angry, not too much. Some of you might be like, this is entirely fine, and some of you might be like, well, this changes everything. Now, if it makes you angry, I'm with you. But if we slow down and over the next few topics, if we slow down and we think about everything that's happening, there's no need to be angry. At least because you can justify why everything works the way it does. You might still be mad, but you could be like, I'm mad, but I get it. Fine. But you'll have to wait over the course of the next few topics for this to make sense. Now, I'm about to get into something that is perhaps a little strange. But it will make perfect sense. You can still be mad about it, but it will make sense. I do my best when teaching people how to program from the ground up to teach programming in a way where we learn this, and then because you know this, we can then do this. And then because we know that, we can do this, and then we can do this. But every once in a while, we get to a situation where it's like, okay, look, in order to do this, we need to know this, and this. But I can't teach you that until you know this, but that doesn't make sense because I can't teach you this until you know that. And then we get into a situation where you really can't tease this out. So, over the next few topics, we're going to be at some stage where you're going to have to, it's not going to be that bad, trust me. I'm just making sure you're aware that if you're like, wait, what? And I go, just give me like 2 days. Just give me 2 days. It's not going to be too bad. Chances are half of you are going to be perfectly fine and the other half are going to be angry. I have to come to terms with that, and you will too. All right? So we're getting to a point where, okay, we need to learn a few things. You're going to have to go with me on a few of these things, but it will all come together in the end. If after a few topics it hasn't come together on the end, tell me. Do me a favor and don't sit there in the room quietly, because if it hasn't come together for you, chances are it hasn't come together for them, or them. And you're all sitting there going like, I must be the idiot. Meanwhile, I'm the asshole who didn't explain it well to you. So, please tell me. The last thing I want to see is a lineup of people at my office hours all asking the same goddamn question when I could have just told everybody that in one shot at the lecture, okay? So, ask. That goes for everything so far and that we will cover in the course, but really over these next few topics, because we are getting it to a point where we have to branch a bit. So, any last questions? You've been warned. Any last questions? All right. Immutability. So, first and foremost, raise your hand if you have ever heard the word immutable before. Do you know what it means?
Can't be changed.
Nailed it. Does anyone know what the word mutable means? If immutable means you can't change it, mutable means you could probably change it. Here's how I remember, and you might think this is ridiculous, but this is how I remember. If I have a TV with a mute button, I can mute it. If my TV has no mute button, it's immutable. I can't mute it, right? I can't change its status, right? So mutable, I can change it. Immutable means, oh no, I'm screwed. I can't make it quiet. All right? All right. Yes? I could, but that's kind of outside the box thinking that we're not going to do right now. So, if I have the string A, and I say print A at index 1. Bless you. I see an E. So if I can, okay, hold this thought. If I have the variable x equals 5, print x. Nothing about this seems weird to you, right? This makes perfect sense. There's no trick question here. Yeah?
I'm thinking a little bit too hard here probably, but when it says print A index 1, why does it print E and not H?
Because we start counting at 0. H is 0. Or 0 would be H. Let me prove it to you. There. The 0th thing. Remember, imagine there is a letter here that's H, E, L, L, O. I say, go to the start of that string and take 0 steps. I'm at H.
Okay.
Take 1 step. I'm at E. And so on. Cool? Yeah? Happy? Perfect. So let's go back to 1. Print, okay, x is 5, print x. I now go x is 6, print x. I haven't hit run yet. What's going to happen? We see the 6, right? If I could assign a value, I can look at the value, I can change the value stored there, and then I can print it back out. Makes perfect sense. So not only can I set the value, I can read the value from that variable, and I can change the value in there. I can write values to that variable, right? So with that in mind, I can set the value of A. I can read the value of A at index 1. A at index 1 equals x. But I can't write the value at index 1. I can't do it. Strings are what we call immutable. You can't change them. So this might be what's pissing half of you off. But there are perfectly reasonable reasons for this that a lot ultimately come down to design and engineering decisions. So it might feel arbitrary, but there's good motivation for it. And B, we have so many workarounds for any situation where you might want to do this that it doesn't really matter anyways. But they are immutable. Once a string is created, you can't change anything about that string. But make sure you're paying very special attention, very careful attention to everything I'm about to say, because I'm going to be very precise with what I'm saying, and the nuance is very important. Because A is a variable that is referencing a string, right? A, it references a string. I'm trying to say, hey, A, go to that string and change something about that string, okay? When I did it with x, which was just an integer, what I'm saying actually means something quite different. Because x is a variable that has the value 5 in it. I did not go to the value 5 and change anything about the value 5. I changed what was stored in x. Going back to the string example, that's not what I was doing. Watch. I will prove it to you. I can do this. Right? This would be the equivalence of this. Okay? Here. Let me draw this. Does anyone in here actually, here's a question for you. Does anyone in here do a lot of like drawing on their computer? What do you use? Like physically, not software, I mean like how do you draw?
My little pen.
You have a little pen?
Well, for my tablet, yeah.
Oh, you got like a tablet. Okay, that's cheating. Does anyone have anything like, what do you use?
I use a Wacom tablet and like a Wacom stylus.
Yeah, okay, I have that too, but I'm not very good at it. Is it like, are you good with it? Is it just me? Maybe it's me.
Maybe, I'm good at it.
You're good at it? Okay, it's probably just me. All right, well, because I ask because I often think like it would be a lot nicer, especially for the recordings, if I could just open up Paint and draw. I should try again, but I'll just use the whiteboard for now.
You can get like screen protectors that feel like paper when you're
Yeah.
writing on them.
I might need something a little bit nicer than that, or like a tablet where it's actually like a little more obvious. Because the problem is there's that disconnect from the tablet from what you're seeing here and what you're doing here, where when it's a tablet, you are drawing on that. Yeah?
Or you can use like Fire Alpaca, that's a software I use, and it's like much easier than Paint.
Interesting. You're making fun of my software now. All right, what is it called? Fire Alpaca? Can you email me that, like a link to that? I'm going to check it out. I'm going to check it out. All right, anyways. Here's what we have. X, right? And X has the value 5 in it. Okay? I printed out X, we see 5. And then I say, all right, go to X and put the value 6 in it. All right, well, that's easy. We just obliterate the 5 and make it a 6. Great, and we print it out. Cool? Cool. Now, we're going to go into a lot more detail on this as we go over the next few topics. But now, for those of you at the back, can you see this reasonably well? If you can't, sit closer next time. It's your fault, not mine. That's what I'm saying. There we go. So here's A. It's a variable, but it's storing a string. It's storing a string hello. And we know that we can't fit hello into like one of these little boxes nicely, as I was showing you. So what we do is we actually create this thing called a reference, which we will talk more about this very shortly. But basically what we do is this, and we create this like blob of information called hello. Okay? Great. Now, on what I have there would be equivalent to me saying, no. Here's what we're going to do. We're going to make a new one here, called it fun, and we're going to change what's in here to reference that new string, like that. Okay? Cool. That's fine. It's happy. We changed what was in here, right? Which was the same thing what we did with the integer. I changed the 5, which was in this box, to a 6, which is in that box. Where here, I changed basically what it was referencing. Again, more on this shortly. If I go back and try to print this out, it won't work. What I'm saying here, like on line 2, don't ignore line 3 where the error happens. On line 2, I'm saying, oh, right, this is like this still. I'm saying, okay, go to A at index 1. That's like, oh, well, that's E. Great. I'm just getting that information. I didn't change anything about this hello. But as soon as I try to say A at index 1 become X, what I'm saying is, what I'm intending on doing would be, well, change this to an X, which is quite clearly different from what I was doing before with the integer. I changed the 5 in this box to a 6 in this box. Now I'm going over here and I'm changing something in this thing, right? But even worse, I can't do this. This is against the rules. Whenever I try that, I get type error. You can't do it. That's not an option. Why? Well, because this string exists, it's created. Once it's created, I can't change anything about it. It's immutable. You can't change it. You might find this frustrating. And we will see shortly, there's a lot of things we're going to see shortly. You will see shortly that we can do this with lists. With lists, you can actually go and modify what's at a list at a specific location. We're going to do that. But you can't do it with strings. And there are a lot of other types of data that you can't do it with. And you might think, well, I guess I like lists because I like the flexibility. You'd be wrong. You might think you like flexibility, but flexibility is the first step in making terrible, horrible, difficult to track down bugs. Because even though it's immutable, we have workarounds for this. Making things immutable, having immutable data is good. It's very, very, very good. Once the data exists and you can't change it, it's there. If you ever need to update it, well, you can't. But what you can do is make a new version of the data. So you never modify what's in here. You make the data immutable. We like immutable. So this is a good thing. You might not see it yet, though. So if I really wanted to make that letter an X, what I would do is I would make a new string where the 0th letter is the same as this one's 0th letter. The letter at index 1 is an X, and then it's the same, same, same. So a new string based on the old string, but I leave the old string effectively alone. You had a question?
Yeah, can you change it to like
So you can't, well, if the integer was stored as a string, the answer is no. But remember that the value 100 and the way that we encode the value 100 as 100 are entirely different. A computer goes 100, that's like 100 things. If I'm counting the number of people in this room, I don't know, there's 1, 2, 3, 4, 5, 6, 7. There's 7 people in this area, right? That number 7 exists. The value 7 exists, but it doesn't exist as this. That's just a symbol. Don't mix up the symbol and what it means. So there's 7 people there. But like, what is 7, really, right? And I know that sounds like I'm being obnoxious, but that's ultimately what it comes down to. 7 is this abstract idea. The symbol 7 is the symbol 7. So going and changing that, I mean, I can change it by adding one more person. That's about it. But if I had the string, like, quote, 100, end quote, I couldn't modify it because it's a string, and strings are immutable. Any other questions about this? That's a good question, though. All right, yeah. Some string index, you can't change it. Why? You can't do that. This is because strings are not mutable. They're immutable. Fancy way of saying once they exist, you can't change them. And we like that. You can go online and find like hours of YouTube video of people yelling at you about why everything you should make should be immutable. Mutable data, the idea of like mutable data, people call it like plopping, where it's like place-oriented programming. They call it plopping. And they picked that name because it sounds bad, and they kind of want to make fun of people that do it because it's bad. You go back to the 90s, late 80s, early 90s, this was all the rage. Everyone thought, this is a great idea. Look at this. We're going to save memory. We don't need to make copies of things and modify it. This is great. And then it didn't take very long for everyone to go like, oh, what a huge mistake this was. And they have to like go and undo like a decade or more of terrible, terrible code. Like this is really bad. We like mutable stuff. Immutable stuff. We don't want it to change. Once it exists, that's it. If you want to change it, you can't, but you can make a copy and then change the copy. You'll notice too, going forward in this course, like even on assignment 2, anyone here work on assignment 2? You have a little bit? If you're working through that, you might not notice it yet, but I've gone out of my way to design it in such a way where you ain't modifying any list. You make a copy of the list and you modify the copy, but you leave every individual list originally unchanged. But you can make a copy and change the copy. All right. However, okay, yeah, so this is what I was saying. It's not mutable. It's immutable. If you really wanted to change it, you can make a copy. And here's an example. No, that's not what I wanted at all. So I want to say 0, 1. This would be like me saying, okay, but that ain't going to work because I can't modify it. So what I'm saying is, from a string, give me all the numbers from 0 to 5 exclusively, concatenate it with the string exclamation point, and concatenate that with the string from index 6 to the end. There we go. I replaced the comma with an exclamation point. Cool, let's make it more obvious by changing it to an, I mean, I could make it multiple things if I wanted, but I changed it to an X. Cool. Now if you're saying, you know, he just went on to say that you can't change it, he just changed it. No, I didn't. And I can prove it to you by saying A string is still what it was. A string was never changed. I made a new string based on the data from A string, but A string was never modified because I can't. Python won't even let me. Any questions, concerns, thoughts, observations, points? Yeah?
I have like a question about the example you showed.
Yes?
You say that once we so you use the example of like x equals 5, x equals 6. You said that once we assign x to 6, the 5 just goes away, but it still prints 5, so would it still?
Here? The 5 is there. Well, no, because x is 5. Print it out. 5. Now make x 6. All right, 5's gone. X is now 6. Print it out. Well, it's 6. So it was 5. So on line 1, it was assigned to 5. On line 2, it's still 5. On line 3, 5 is obliterated and it becomes 6. And then on line 4, we print out the 6. Remember, the code is not static. The values of these variables, you might be like, it's x. X doesn't, you know, x is, no, they're not equality statements. They are assignment statements. And the code runs one line at a time. So it's set to 5, it's still 5, we print it out. It's set to 6, it's still 6, we print it out. That's what's happened. Is that clear? Perfect. Perfect. Good question. Other questions? Now's a good time to ask. Perfect. This right here, this next topic, could effectively summarize this whole course. Right there, linear search. That's all this is about. Everything you do in this course is working towards this idea. And you've already done it several times. And you're going to do it several more. Anyways, we'll pick up here tomorrow.